Good evening. Welcome to the British Tunnelling Society's October lecture. Tonight's lecture is on the Greenwich Tunnel Boring Machine Delivery, the abridged story. Tonight, I'm very pleased to welcome two speakers. Our first speaker is Robert Margariti-Smith, who is a tunnel manager at CVB, working for Costain, delivering the Tideway Greenwich Connection Tunnel. He has been working in the tunnelling industry for the last 13 years, from the smaller 3 metre and 2.8 metre diameter West Ham and Brighton schemes respectively, through Crossrail on contract C510 Whitechapel and Liverpool Street stations, before venturing east to Singapore and the construction of the Thompson East Coast Line. Time on Tideway has been spent with the secondary lining consortium, looking at a precast secondary lining and latterly the delivery of the Greenwich Connection Tunnel. Our second speaker is Conor McQuade, who is a senior project manager with Mammoet, working on major infrastructure projects in the UK for the past 5 years. Originally hailing from Belfast, but having left to pursue a career in heavy lifting and transport with an Australian-based provider. Conor spent 4 years working as project manager within the Australian heavy lifting industry, including time as project manager on the new build Longford gas plant in Victoria. Upon returning to the UK, he has worked on many major infrastructure projects, including managing heavy lifting and transport scopes as part of the Tideway project. And I welcome now our first speaker.
Good evening, and thank you for joining us on this Thursday evening to run through the delivery of the Greenwich TBM Shield, which is 1094, the HK numbering. I am hoping that the technology works. So a quick overview then of what we intend to cover. So the challenge which was set out, which is ultimately delivery of the TBM Shield from Germany, where it was manufactured to the job site in Greenwich. The problems and a bit more detail on those. The solutions, and there was a variety of, and finally lifting into the shaft and to the position that we're in at the moment. So for those of you who are not familiar with the Tideway route map or the project, it runs from Acton in the west over to Abbey Mills in the east, and then into the Lee Tunnel and out to Beckton. The site, or the job site that the tunnelling machine was to be delivered to, is at Greenwich, which is earmarked on the map just there. A couple of facts. So the TBM's been named Annie. Annie after Annie Maunder, who was an astrologer at the Royal Observatory in Greenwich, first female astronomer. So the shield weight is 464 tons, is 12 meters long. The total length of the TBM, including the 9 plus backup gantries, is 148 meters, which is 6.44 meters in diameter. And the planned delivery date into the UK was the summer of 2019. So just to give a bit of scale as to what it is that we're delivering from Germany. A little bit on our job site. So the Greenwich launch site is hemmed in between the old Greenwich pumping station, which is an active and serving pumping station for the borough of Greenwich and Deptford. The DLR and Network Rail viaduct, and it's located up Deptford Creek, which is tidal, and we're on the wrong side, unfortunately, of the listed or the grade listed lifting bridge, which is positioned on the Network Rail viaduct. And as you can see, we're a fair way off the River Thames. So unlike some of the other launch sites along Tideway, not quite so straightforward in delivering the TBM by barge up the river and just offloading it from the quayside. A couple of the site constraints, aside from the Network Rail viaduct and the DLR viaduct, preventing delivery from the north side through to the south side and into the shed. We've also got the pumping station, which, as I mentioned earlier, is an active live asset of Thames Waters, and so they have their operational facility on site and need access. They also need to maintain the emergency access in off Norman Road, and that's also our shared site main access gate. So surface space is quite constrained, and as a result, the option to build the TBM shield on the job site was not there. So that left us with a problem to find somewhere local to either build the machine or get it delivered into. And so started a process back in early 2018 of reviewing different delivery options. So a couple of options which were looked at early doors was to deliver the TBM shield in its sort of constituent components up the creek on a high tide, unload them on the north side of Network Rail and DLR, and then lift them over. But the radius of lift and the weight of the load, the crane mapped foundation, almost rendered that option immediately non-viable. Add to that heavy lifting over a Network Rail and DLR track, what wasn't particularly keenly taken up with either of the providers. Other alternatives which we looked at were delivering by road from Germany, the TBM shield in its constituent components, and we looked at assembly up on Blackheath Common, down in towards Deptford, a couple of sites which were due to be developed upon, but unfortunately the sites which we were looking at were earmarked for development in either spring, summer 2019, and we weren't able to confirm at that point in time that we were able to remove the TBM shield in time for the development. And that led us then to look slightly further afield, and Vic Deep, or Victoria Deep Wharf, which is a Hanson's batching plant, became a viable option for delivery. We could deliver the components in pieces and then transport them via road as a complete unit, and then a multitude of different road options were looked into, but various challenges met along the way. Obviously the Blackwall Tunnel Approach Road, which is the A102, offered quite a few challenges with low gantries on the approach and pedestrian bridges, and alternative routes crossing the Network Rail alignment also posed various challenges, predominantly on height. And ultimately we sort of settled on at that stage the route highlighted in red. There was a couple of detailed route surveys undertaken by abnormal load hauliers at the time. It was deemed the route most suitable with the least amount of work to get it into a state of delivery, and also with the least number of structures along it. So a quick overview then, a screenshot almost taken out of EastEnders, where you can see Vic Deep Terminal at the top, which is where we were to unload, and then the job site circled down at the bottom. So, true to planning, in the summer of 2019, I seem to remember this was in July. It was a very hot week. Mammoet assembled a 750-ton mobile crane, about 16 meters back from the wharf front. Again, we struggled with historic impact assessments of a pretty old quayside, and despite Hanson using it day in, day out to unload barges, the temporary works designers weren't very keen with us loading similar loads so close to the wharf. So we assembled a 750-ton crane, and the TBM was then delivered through in two barge loads to the quay. We unloaded it, put the components onto trailers, and then took the trailers down to the other side of the Hanson site, where we had rented about 2/3 of an acre, and it was to be the area where we would then rebuild the TBM shield. So a couple of photographs here of the TBM shield reassembly over at Victoria Deep. So it was just delivered in 11 components, including the cutter head and tail cam. And we then went through about an 8-week reassembly phase, and we also had room on site to store the 9 backup gantries in the bridge. So with the TBM components now in Vic Deep, and the route survey as shown on the screen, now semi-rubber stamped in terms of where we wanted to proceed. We then sort of handed over a little bit to Mammoet to make the application for abnormal load movement. And at this stage, we also got the local council, Royal Borough of Greenwich, involved, TfL and the like, around a table. This was back in October 2018. And I guess little did they know at this time quite how involved they would become in this transport. But to give you a better idea of exactly what it is we were looking to move, I'll now hand over to Conor to run through the SPMT.
Thanks, Rob, and good evening, everybody. On this slide, I appreciate that some of you may be very familiar with SPMT, but there may be some of you that have never used these type of trailer before. So on this slide, I'll just allow a video to play in the background, which shows how the SPMTs can be used and how they can be coupled together. So SPMT is a self-propelled modular trailer. These are multi-axle trailers that can be connected, in theory, to make any sort of size trailer. Typically, we use them in 4 or 6 axle units that we couple together. 4 or 6 axle units because it's quite easy to transport, but there are other size trailers available. We can couple them together, front and back, left and right, and make a bespoke trailer depending on the requirements. So in this instance, we had to find a trailer that allowed us, one, to carry a 630-ton item, but 2, we also had to consider the fact that we were taking this item through the centre of London. So we needed to maintain as low a ground bearing pressure as possible, which we can achieve by adding additional trailers and making the trailer longer. But then we have to also consider the fact that we're travelling through old Victorian streets and going through the centre of Greenwich with a lot of tight turns, and we needed to keep the trailer as short as possible. So having taken everything into consideration, we chose a double wide 12 axle trailer. This allowed us to make the load per axle be quite low at 13 tons. Each axle, its capacity is around 24 tons. So we were utilising, in terms of its capacity, only around 50%, which translated to a ground bearing pressure of 7.7 ton. The other advantage to using these trailers is that we can self-load the unit. We don't need a crane to load. So the trailers themselves have a 600 mil hydraulic stroke. So at their lowest level, they're 1.2 meters high. At their highest level, they're 1.8 meters high. And so at Vic Deep, when we came to pick up the TBM, we drove the trailers underneath the transport cradle and raised the hydraulic stroke of the trailer, which freed the TBM from its stools and allowed us to then drive out and onto the road. Rob, if you can skip us on one slide, please. So after selecting the trailer, our next task is to then inform all the necessary parties, all the statutory authorities, about our intentions to move. So originally, our first submission to ESDAL. ESDAL is a government-run service. It stands for Electronic Service Delivery for Abnormal Loads. The process is to inform ESDAL. This then gives a notification to Highways England, and Highways England then go out and inform the major parties. So they'll inform the police, in this case TfL, Greenwich Council, and a number of other main statutory bodies. So the first submission in 2018, at that time, our information was that the TBM shield and cradle would be around 490 tons. So we made our submission at that point, and relatively quickly, we received our first positive confirmation that we could proceed. Network Rail had an asset along the route, which was a bridge in Greenwich. And they very quickly replied to us that they had carried out an assessment that the bridge was strong enough and we could proceed. In that time, we then were waiting also for TfL and the police and some of the other statutory authorities to give us approval. One thing to note as a good lesson learned for anyone who's going through this process, ESDAL isn't a one-stop shop. It's an approval to travel. This is how we obtain our permit to travel. But in addition to obtaining a permit, it's also important to inform other potential asset owners along the route who may not be part of the ESDAL system. So we collated a list of about 20 to 25 different potential asset owners along the route and informed them of our intentions. And the vast majority of those had no issues. But we did have some response from Scotia Gas and from Thames Water that they would like some further information before giving their approval. Then around 2019, around June 2019, we had a notification from our client that the TBM was a little bit heavier than expected. So rather than being 490 tonnes, it was actually 520 tonnes. Because of this change, we then redone the ESDAL process. And very quickly, we received a reply from Network Rail to advise us that actually their original assessment was incorrect and that they didn't any longer give us approval. They wanted to see a further analysis of the bridge in Greenwich before giving approval. We also had to do some further impact assessments. So when we travelled across the Blackwall Tunnel, the North Greenwich station, we performed those impact assessments and Cat 3 checks relatively early in the process and obtained approval relatively quickly. For SGN and Thames Water, they had a number of assets all along the route that all required further impact assessment. And I think Rob will probably tell us a bit more about those.
Thank you very much, Conor. Yes, I will give it my best shot, but please bear in mind that I am not a designer. So as well as the more obvious structures that needed checking along the route, as Conor mentioned, Mammoet notified some third-party utility companies, and it was identified that Thames Water had a series of clean water assets, as you can see detailed on the map, along the route, which had varying diameter, material, and of age, which required a little bit more in-depth analysis. Thames Water Ops also undertook a suite of functionality checks of the trunk main valves along the delivery route to ensure their operability. And we also reviewed burst history hotspots along the delivery route to check or to sort of ensure that there was no areas that would be of higher risk for future bursting. At this point as well, the ops team Thames Water Ops started discussing within their team about having a contingency team available on the night of the move in the unlikely event that the damage was caused to any of their underground clean water assets. There was also a detailed assessment undertaken on the wastewater assets. Typically, if you've got clean water assets, there was also wastewater assets in the vicinity. So those which were of a concern to Thames Water were then further investigated. There was CCTV surveys undertaken of some of the smaller assets, and also ferro scans undertaken to check and confirm that reinforcement was within the concrete lining of the sewer, which then allowed them to pass the assessment. There were a couple which were along Millennium Way. I'm going to try and use some technology here and we'll see how it goes. Not very well. Hopefully you can see my cursor, which is this road down here, and it's a dual carriageway. There was a couple of instances whereby switching the SPMT to the other side of the carriageway, we were able to get out sufficiently of the impact zone of those assets and thus no longer impact them. And there was a couple along Blackwall Lane, which is section of the route here, which were sort of only just passing assessment, and Thames Water advised that they would rather have them lined if possible, and so in record time we were able to get a lining contractor out, and you can see in the photograph in the top left hand corner, over a couple of night shifts, they worked through the night and got this run of sewer lined. Thames Water also own a series of trunk sewers, I guess to my surprise quite a high number, 3 in and around Greenwich and under the TBM delivery route. But these are larger diameter sewers. There's the storm discharge culvert, there's the East Greenwich relief sewer, and there's also the southern outfall number 1. These predominantly lie underneath the roads. So the storm discharge culvert and the EGRS both passed the assessment, and condition surveys also showed that the sewer lining was in very good condition, and you can see a photograph of a still there taken on the left hand side, which despite their age shows the brickwork to be in exceptionally good condition, and the sewer to be of a good serviceability. SOS1 had a roughly 100 metre long section at the junction between Trafalgar Road and Blackwall Lane, which failed the thrust line assessment under the 12 axle and TBM load. The margin of failure didn't indicate that there would be structural damage, just moderate damage, potential cracking of brickwork, and potential dislodging of individual bricks. However, under HB30 highway load check, it was also shown to fail by a slightly higher margin than the TBM and SPMT load. But again, this stretch of sewer was surveyed and found to be in good condition. The design assessments which were being made on the sewers were not overly straightforward, based primarily on unknown condition of assets. Many months were spent between the design houses discussing different assessment methodologies, refining their inputs, parameters, with many meetings held on the various outputs. And we also had OTB undertaking assessments on behalf of CVB, and PIE were acting as checkers for Thames Water, as well as their own internal team led by Tom Smulders. I'll be honest with you, as I said at the start, I'm not a designer, and most of the design at this level went way above my head. But it's safe to say that there were some pretty fine minds looking at these assessments and undertaking them. And this was then to spill over into the assessments which were being made of the gas mains, which were now being run in parallel to the water mains. So SGN have a variety, or quite a long list of assets, which are along the delivery route. So these were tabulated. Those which passed the initial high-level assessment were then removed from the table, and they were whittled down to the collection that you can see on screen there. And these were the assets which were sort of causing us and SGN and the designers the most trouble. The problem with the gas mains, similar to the water mains, is that they are typically quite old, up to, in some instances, up to 140-year-old, cast iron, up to 1.2 metre diameter, medium pressure gas mains with the old lead cork joints or lead yarn joints, which gave the designers a bit of a headache when looking at parameters to input into the calculations. So DMVGL were employed by SGN to undertake the impact assessments on their behalf, and off the back of the Thames Water assets assessments that OTB had done for CVB, they were also asked to undertake a check on behalf of us. The main problem is the condition of the assets and what condition they're in. There was a relatively unknown amount of information in terms of not only depth but also bedding material and the condition of the iron after the number of years that it's been in the ground for. And this led to quite a bit of conservatism, I suspect, going in at most stages of the calculations. and as a result, the acceptable criteria for passing over was also pretty conservative. There were instances where some assets were shown to be failing even with just the overburden alone, and no traffic load on top at all. At this stage in the game, CVB with the local council, so Royal Borough of Greenwich, and also some of the other councils, surrounding councils, TfL, the Met Police, and ESDAL, looking at the system as a whole, started to look back through all of the historical load conditions that the road and subsequently the assets had felt before, in order to, one, assess previous historical loading, and two, to provide some additional comfort to the asset owners. In addition to the other assessments which are being undertaken, we were also looking at surcharges, sort of a very basic surcharge pressures on the assets at varying depths. So a basic assessment was undertaken, calculated using the Boussinesq method, which is used to determine stress at a point of depth as a result of surface load. So there's a couple of assumptions in this assessment, which is what kept it relatively high level. But the soil mass is a semi-infinite, homogeneous, and is isotropic. The soil has a linear stress-strain relationship, and for the sake of calculation, the soil was added as an assumed unit. Sort of again, the main aim of this calculation was to demonstrate that the surcharge loads of the SPMT with its payload were not significantly greater than those that the assets see on a day-to-day basis, and that we were potentially within the operational window of said assets. So in addition to calculations undertaken using various different models, we also undertook some physical trials. So here you can see only half a TBM shield, as it happens, sitting on a cradle on the twin 12-axle SPMTs, and on a small section of road just outside the Victoria Deep site entrance. We ran a couple of tests of about 100 meters in length, measuring surface deflection or pavement deflection. We'd also undertaken a number of plate bearing tests along the route on the substrate, one of which you'll see in the photograph was taken just in front of the SPMT here. You can see the backfilled tarmac. We'd also undertaken a number of cores at varying intervals along the route to determine the pavement makeup and varying thicknesses of pavement and bedding substrate. We also undertook falling weight deflectometer testing along the complete length of delivery route for back analysis, again to try and determine the makeup and strength of the pavement. And this was then corroborated with the cores which had been already taken. And this information was then being relayed back to the designers to try and help them refining calculations in terms of stresses that pipes and joints would feel with the load travelling across the top. Prior to this, we'd undertaken a GPR survey along the full length of the route to identify any voids or basements which extended out under the road along the route, and also to see if there were any historic tunnels between Greenwich Park and the Royal Naval College, as it used to be a hospital, and there have been historic documents which detailed tunnels which cross between the two, allowing water to be taken from underground reservoirs in the park across to the hospital. However, nothing had been found, but it did show up some areas where pavement had delaminated. So again, we were able to look at those areas in a little more detail. So as a byproduct of the various design assessments which have been undertaken, both for Thames Water and also for SGN, and also, as Conor mentioned earlier on, the Network Rail bridge issue. For those more observant, you'll note that the TBM shield is now only half a TBM shield sitting on the back of a 12-axle SPMT. We'll get onto that in a moment, but this is what the 12-axle SPMT configuration looked like with the half TBM shield on, with the ground bearing pressure now at 4.5 tons per metre square. And that 12-axle SPMT configuration would take us from Victoria Deep, and for the first kilometre of the journey, down Millennium Way, across the A102. Once we'd crossed the A102, we were then looking to utilise a 24-axle SPMT configuration. So this was to stick an extra 6 axles on either end, connect them up. And we were then able to run a 24-axle SPMT between the A102, Blackwall Tunnel Approach, and Greenwich Town Centre. Now, as Conor's touched on before, Greenwich Town Centre is pretty tight, and there are some narrow roads for which we would not be able to get this around the corner of. So the intention was to drive into Greenwich Town Centre, take the 6 axles off the front and the back, drive the 12 axle around the corner, before then coupling back up again in a configuration to pass over the Network Rail Bridge. So in 24 axle configuration, we've now got the ground bearing pressure down to 2.9 tonnes per metre square. In order to get over the Network Rail Bridge, a quite monumental SPMT was required at 36 axles, and now dwarfs the TBM shield sitting in the middle. But getting this or in 36 axle configuration, we now had the ground bearing pressure down to a level which was acceptable to both Network Rail and Tony G, who were undertaking the impact assessment on the Network Rail Bridge, in order to gain consent to pass over. So this would have been recoupled up, having gone round the corner in Greenwich outside Bills, and then would have proceeded up towards the job site. Obviously, with the 24 and 36 axle configuration of SPMT, another and more in-depth swept path analysis through all the corners of the journey was required. So here you can see on the left-hand side the 24 axle SPMT navigating the corner between Blackwall Lane and Trafalgar Road. You can see we just about make it. However, as I'll touch on in a moment, there's quite a bit of junction street furniture which needed to be taken out to facilitate this. On the right-hand side, you can see the 36 axle SPMT just after Greenwich Town Centre and the corner between Greenwich Trafalgar Road and Greenwich High Street, which would have been coupled up and then navigated up and around the corner and across the Network Rail Bridge and then off towards site. So from the very first route survey which was undertaken, it was identified that 9 junctions needed to be modified either partially or completely, and turned from what they are at the moment, which is a physical junction, into a temporary demountable junction which could be removed easily on the night, level to the road surface to allow the SPMT to sweep either over the top of it or to completely pass over the top, so free from all street furniture, traffic lights and CCTV cameras and the like. And this work was to be undertaken by Kia on behalf of TfL. So they then set about their application process to go out and start modification on the junctions. So at this point in time, apologies to the residents of Greenwich, because we caused quite a bit of disturbance as we worked our way through making modifications to the junctions, but Kia did a super job and got those all done on time. In parallel to all this work being undertaken, we were holding monthly meetings starting back in October 2018 with all the affected third parties, council and utility providers. Over time, these meetings grew in their number of attendees, but it's definitely safe to say that the support of the third parties throughout this entire process has been excellent, and it's a pretty complex package of work. So we arrive in early March 2020 in this position here. So as detailed, we've now got the SPMTs navigating the route in 3 different axle configurations. We've got all the junctions are now installed or have now been changed for a demountable junction that need to be so. Kia have completed work on the A102, changing out the central reservation for a demountable section to allow us to go up the on-ramp across the A102 and off the off-ramp again. The height of the load on the SPMT was not able to undercross that road. And we were almost ready to go. There was an exceptionally large team required for the night of the move, around 200 personnel, or in fact just over 200 personnel in total at last count, consisting of the CVB team, the Mammoet team. Met Police had about 25 officers, both on solo bikes and cars. Kia had their teams out, dotted along the route, ready to demount the junctions, and also to provide an element of traffic management. Cone masters were also out providing traffic management for pre-work that needed to be done in advance. Thames Water Ops and their management team, SGN Ops and management team, Tideway, Royal Borough Greenwich, TfL, and lastly a CVB contingency team, and all the equipment for the contingency team to satisfy or to meet the expectations of the third-party utilities companies and our ability to deal with an emergency in the unlikely event that one comes along. In parallel to all this work, obviously work on site continued, and I'll now hand back over to Conor just to run through the work which was being undertaken on site in parallel to the route preparation.
Thanks, Rob. So as Rob mentioned, we're now in early March. And over the course of a week or two at the start of March, the drawing that you see on screen now is what we built on site. This is a bespoke design built specifically to lift this TBM. It's built from component parts owned by Mammoet. There are a number of challenges in building this and getting this to site. A lot of this equipment came from the Netherlands. So we had quite large pieces of equipment that we were bringing into a very small site. We have, at the base of this system, we've got 16 metre beams which span the shaft left and right. Above that, we then have some skid track, which is used to move a 4-point lift system left and right. So on top of that 4-point lift system, we then also have 4 300-ton capacity strand jacks, and these are essentially jacks with large steel strand wire coiled at the top, and these can be then uncoiled to lower the TBM to the bottom. So Rob, if you can show us with your pointer, if you could just point to the east end of the shed, and I'll just explain. So the idea is that the TBM would arrive through a mega door on the east end of the shed, and it would park up on the ground where the cursor is at the moment. The system that we have built, the 4-point lift system, would then be skidded across on top of the TBM. We would connect the strand wires to the transport cradle below the TBM and lift the unit off the SPMT. The SPMT could then leave via the mega door, and we would skid the full system across to the top of the shaft. And then we would lower the strand wires to lower the TBM to pit bottom. And that process, the speed is about 10 meters per hour. So it's a full shift to lower the TBM to bottom. As I said, we built this system in the first 2 weeks of March. So by now, when we're ready to receive the TBM, we're into mid-March. And at that point, COVID-19 strikes and things start to change.
So yes, then COVID-19 threw a spanner in the work. So as I mentioned earlier, the numbers involved in the move then needed to be drastically reduced in order to work under what is now the new normal, and we are all living with social distancing and minimal physical interaction between the teams. So this is sort of mid to end March. We're in the throes of what is sort of the lockdown, as it were. I think it's also important to say that SGN was still not comfortable with the move of the TBM shield on the SPMT, and they were still undertaking design work, and as were we. So it got to a point where between CVB and Tideway, we made a hard decision that really splitting the TBM shield down back into its original 11 components and would then deliver to site on a more conventional abnormal load delivery was probably the best way to go. No one knew then how long COVID-19 would be around for and what impact it would have going forwards. The Met Police were then overstretched and were not able to provide support to the move as a escorted load. And so we were sort of in limbo, and this got us out of that limbo. So work on dismantling the TBM shield at Vic Deep, although gut-wrenching, having spent so long building it and working on all of everything we've discussed thus far. In April 2020, work started then dismantling. This also meant that we needed a different method of lowering the TBM down the shaft, as the strand jacking system is perfectly adapted to lift one single piece and lower it down. It's not quite so versatile when it comes to the ability to lower multiple pieces and position them in the shaft. So we then needed to have a look at an alternative option. Before I hand back to Conor, a couple of snaps of the cutter head and tail can, which were the two largest elements that needed to be bought by road in the constituent pieces, being brought across the A102 and the Blackwall Tunnel approach road with the road closure and through the central reservation. For time's sake. Conor, back to you, mate.
Yeah, thanks, Rob. So as Rob mentioned, we go from a TBM, a single piece, which was a relatively straightforward move, simply up and down, to having 11 pieces, which we now need to have some sort of left and right shift because the pieces are to be reassembled at the bottom. So we need to be able to access all areas of the pit bottom. So we had to think of something that gave us a full range of motion at the bottom of the shaft. So our first thought was simply, can we put a crane inside the shed so that we can still deliver each of the component pieces to the east mega door, have a crane pick the pieces off the back of a trailer, slew 180 degrees, and then lower the components to the bottom of the shaft. This wasn't possible because of the size of crane needed. It would have been far too big to put into the shed. It would have clashed either with the shed walls or with the roof. So we had to discount that idea. We then looked at the possibility of putting a very large crane outside the shed and lifting the pieces from the back of the trailer through a hole in the roof and lowering everything to the shaft bottom through the roof. I mean, obviously there's a whole load of issues with that, but the main one probably being that the DLR runs right outside, and I don't think we would have ever had approval to put such a large crane so close to the DLR. All this is, as we're working through these options, it's all in the middle of this COVID period where everyone's working from home, and we have around 8 weeks to come up with a brand new concept. We have to then detail the engineering. It's got to have a Cat 3 check, then we've got to deliver and build it. So it was quite a mammoth task. And what we've come up with was something that we have never seen before. It's a totally new bespoke idea. But to minimize the amount of engineering, what we thought we would do was we would still utilize the skid track that we had from the previous design. And we would somehow use this to shift both the crane and the load. The heaviest load that we would have to lift is around 80 tons. So you don't need the biggest crane in the world to be able to lift 80 tons at short radius. So our thought was that we would lift at a short radius with a crane and find a way of moving the crane and the load simultaneously. And what you see on the right-hand side of the drawing is that concept. So we've created a platform upon which to set the crane that we can then skid forward and back. And then when we're above the shaft, we can slew the crane left and right. And between the two, that gives us our full range of motion to be able to set the pieces at any point at the bottom of the shaft. If you would like to go to the next slide, what we see now is some actual pictures of what the design looked like. So we had a number of concerns about doing this. The main one being, as you can see on the left, it would be a bit disconcerting for any crane operator to be operating in his crane above the shaft. So we used a brand new state-of-the-art 350-ton crane. This crane arrived into the UK about 4 or 5 days before it actually went to site. So you can see that it's so new, it's very shiny and doesn't yet have any Mammoet stickers. So it was literally straight from the Liebherr factory, straight onto site. And this allowed us to have the operator, you can see the operator carrying out a lift on the right-hand side. He's using a Bluetooth controller, and it means at no point does he ever actually need to be in the crane when he's performing the lifts. This meant this gave us our confidence in being able to do this and make sure that we were never putting anybody under any danger or undue stress. We could then always skid the full system forward and back to put the system above ground and allow the operators then to access the crane at any time to perform their daily checks. We have you can see from the pictures, we've got a scaffold platform with some ladders that allows the operators, when the crane is skidded above ground, to access all areas. And just because a lot of people question me and say, did we accidentally put the Mammoet beams the wrong way around? I'd just like to assure you that's exactly how they should be. They are multi-use beams that we can use in a variety of different ways. And in this occasion, that's the correct orientation. It's something that a lot of people have asked me about. And that was, in the end, around 3 weeks from start to finish of picking the first TBM piece to the last one and reassembling in the pit bottom.
Thank you very much. They say a picture speaks 1,000 words, so here comes a 4,000 word slide. A couple of photos, or 4 photos, of the crane in action at the top, lifting the cutter head and the front shield lower section. So it worked very well. Lifting the component off the trailer. We then took about half an hour or so to skid the crane back. It was very, very smooth, no jerking action at all, which I know was another concern raised pretty early on. And then lowered those components down into the shaft, where we then set about rebuilding the TBM shield. We'd now become quite good at building this TBM shield, and the HK guys, this was their 3rd time building it. So the first time in Germany for the factory acceptance, the 2nd time at Vic Deep, and now again back in the bottom of the shaft. So it went back together very quickly, thankfully with no problems at all. So almost there. A couple of lessons learned. What to take away from this experience? I guess to start off with, do not underestimate the difficulty of delivering anything on the road in London greater than 130 tonnes. I say 130 tonnes, that's sort of the upper size of a piling rig or de-walling rig, and some of the heavier mobile cranes. They tend to rattle around with relative ease and slip through the ESDAL system almost unnoticed. Anything outside of that then sort of gleans the attention of other interested parties, and therein in the sort of design impact assessments start. Whole TBM delivery to a site not on the riverfront, I would not recommend. It raises this whole host of problems. Undertake these assessments at an earlier stage, back during feasibility or DCO stage on this type of contract. Get engagement with the stakeholders and utility owners very early on. Ensure they understand exactly what it is you intend on doing and the loads. I mean, we started 20 months back, which at the time seemed like to everyone all the time in the world, and we worked pretty hard. We hit the ground running from pretty early on. And it still, I wouldn't say was long enough. There was a lot of very, very long hours worked by everybody in the last few months. We had people working all hours of the day, night and weekend. So that above earlier sort of engagement would then drive or determine a method of transportation and potentially alter intended drive sites for TBMs of this diameter and larger. To utilise historic and current traffic loading as more of a basis for assessment rather than how we used it, which was more of a ratification of or more disproving of assessments, not really the right way to term it really, but we sort of used it at the wrong end of the assessments really. We should, in my opinion, have been using it at the front end. Ensure that you get early cross-party agreements on assessment methods from the very outset, and a global buy-in of all involved of the accepted level of risk that could be taken forwards. Depending on stakeholder and depending on party, everyone has a different sort of appetite for risk, I guess. And we learned very early on that the earlier we sort of all sit around a table, decide what would be accepted and what wouldn't be accepted, cleared the way then for decisions to be made. Where delivery by road cannot be reasonably achieved, ensure that there is sufficient space on site to permit a rebuild of a shield on surface, and then subsequently lower it down whole. Obviously, we're working on a particularly tight site here. Ensure that the TBM designs accommodate loads which can be transported by road under conventional abnormal load orders. We were we weren't lucky. The TBM had been designed such that it could be broken down for transportation from early doors, but it could have easily not have been, which would have left us in a bit of a sticky situation. Never underestimate the scale of challenge or the sheer number of person hours required. I know when we set off, the first couple of workshops and meetings that we had, a couple of people turned up, and we rattled off actions pretty quickly. As it grew and grew, the number of people involved and the number of hours that everyone was putting in also snowballed. And lastly, as Conor's mentioned before, the ESDAL system is only an approval to travel. So we got our abnormal load movement order. However, it is by no means the complete A to Z assessment, and that still lies on the haulier or the contractor to undertake that check. From me, some final thanks. The logo of the company is on the screen at the moment, have all played a part in the delivery, and apologies if anyone has been missed out, but I guess a big thanks to Royal Borough Greenwich. We have up until now been a bit of a nuisance, and I know that they probably dread a phone call from me, but with that said, they've also been extremely supportive of the move, both to ourselves and also Kia, who've been along the route making various changes. Over to questions. Thank you very much for your time. Okay, so in answer to the question of why was the option used, not the preferred option from the beginning. In the works information, it is a requirement, or it is a requirement in the works information to lower the TBM shield, or to assemble the TBM shield at ground surface or at ground level, unless it could be demonstrated by risk assessment that health and safety risks with below ground assembly were lower. So we always set out from the very beginning to have the full TBM shield lowered in the shaft. With that, which is why it drove looking at other areas away from the site where we could build the TBM shield and get it delivered in and lowered down on the strand jacking system. And it's something which has been replicated across all of the other tideway sites. I think without exception, they've all built their shields on surface and then lowered them down the shaft.
And if I can just say as well, in terms of putting a crane onto a skid table, I believe this to be the first time this has been done. I certainly am not aware of it, and within discussions internally with Mammoet, no one that I've spoke to has ever seen this done anywhere in the world. So it is a very innovative solution, and one that we came up with specifically because of the challenges of COVID and the fact that the TBM shield was split at the last minute. So it was not something that we would normally have ever considered before.
So, answer to Michael's question, there weren't actually any complaints that I'm aware of anyway. Maybe the community relations team might tell me otherwise, but as far as I'm aware, there weren't any subsequent complaints from stakeholders, and post-move surveys undertaken of the structures haven't shown any damage caused on the route. So all in all, a success. In answer to Ender, I am not sure.
It's a very difficult one. So we, as the transport company, we obtain our permit from Highways England. So ultimately, we had approval from the statutory authority that we could carry out the move. But then that's a good question, specifically for some of those other utility companies that weren't part of that install process, and where that risk lies is probably something that is up for interpretation, debate, I would think.
I think if we've got any other questions, if people could post them in the chat, that would be great. I think probably for me, I think we had a little bit about, oh, hang on, we've got one that's just come in.
So from Derek, it's a 350-ton reusable. I assume the 350-ton you're referring to is the TBM shield, and arguably yes, the TBM shield is reusable once the works are complete. We are able to remove the shield from the ground at the other end, and it either goes back to HK for remanufacturing, or they use the components out of it for another machine. If you're referring to the 350-ton crane, then yes, as soon as we'd completed the reassembly of the TBM shield, we put the wheels back on it again, and it drove off onto its next job. And I'm sure it's being kept very busy.
Yeah, and just on the crane, I didn't specifically mention it during the presentation, but as Rob says, and you might have noticed on the pictures, the 350-ton crane did have its wheels removed. Because it had to be lifted onto the skid platform. It was too heavy to be able to do that with the wheels attached. So we removed the wheels. Because the wheels are also included in the calculation of the crane's counterweight, we then had to derate the crane as well. But when we took the crane back off the skid platform, we refitted the tires, and then, yeah, of course, it's been very busy since.
Also, in terms of reusing things, the strand jacking system, the subsequent or solution and design for that 350-ton crane on the skidding table utilised as much of the strand jacking system steelwork as we possibly could to prevent the need for more components to be transported to or from storage over in the Netherlands. So as much of that system was utilised as possible. Yeah, Conor.
Not in 2020, but they would have been useful.
It was looked at, but it's the underside of a hovercraft. with the air cushion that it sits on, I believe exerts the same amount of load down onto the ground as it would normally by wheels, just over a sort of slightly more uniform area. It doesn't get rid of the weight anywhere. And I guess arguably it could be more if you're also forcing it off the ground. But whether you say in jest or not, I don't know. But it was certainly discussed around a table at one stage. I remember it vividly.
I mean, there are some things just on that. So you talk about hovercraft, when we were crossing the network rail bridge at 36 axles long. One thing that we looked at is we can actually pin up the certain axles. So in theory, when we have a trailer that's, for example, 36 axles long, we could have pinned up, the middle 12 axles, and as we were driving, we could, in theory, lower and raise axles. So you can create a bridge, if you like, so that you're not exerting any pressure on a particular problem area.
I'd got one. I was wanting to know a little bit more. Obviously, with COVID, you then had to kind of come up with another plan really quite quickly. How did you get that through so quickly? It didn't sound like you had a very long period of time to plan it and get all the agreement.
So by this time, I was definitely running short of favours. And again, it ties back into the sort of amazing amount of support, I guess, in a way, from all the third parties involved, the local council, TfL. Everyone was amazingly receptive to the change of plan in terms of the transportation. In parallel, there were still ongoing designs and design checks being made. Obviously, the load configuration, albeit lighter, has changed as well. So the axle spacings are different, the number of axles are different, the widths are different. So there was another rerun of impact assessments done. So the designers were kept busy and some more long hours put in by them. And then in terms of the brainchild of the option, a lot comes down to Mammoet, and again they were working pretty tirelessly in the background, and again working long weeks to get all the designs in place, get the designs and the design packages submitted to ourselves for us to then undertake Cat3 checks on them and get them submitted and approved, again through all the various different interfacing third parties, so that everyone was continually on the same table. I think, in short, what had started out as a sort of a third party interface meeting between ourselves, Mammoet, Tideway, and all of the sort of stakeholder parties, ultimately turned into an extended, I'll say, friends group. It certainly felt like it. Listing in the hundreds of all the various different parties and parties. So we were able to, with that relationship that had built up over the last 20 months, we were then able to streamline applications and get things really moving quite smoothly. And as you say, it was amazing, considering everyone had to up from their desks, move into their living rooms, spare bedrooms and what have you, and turn to working from home, and yet still be able to deliver very, very quick turnaround times, and very thoroughly as well. And ultimately the move, the cutter head and the tail can, as I mentioned, they were the two largest components that needed to be moved. They were still moved with police escort, and there was still a lot of junction modification that needed to be undertaken to facilitate that. And again, all the way through, everyone was extremely professional and we held a sort of a pre-start meeting up at Vic Deep at 10 p.m. with the police and all the Mammoet guys, and everything went very, very smoothly. I'm pleased to report.
Yeah, I think definitely a lot of lessons learned, and I also like sort of what actually happened once you'd reached the site, in terms of obviously when you went from the 1 piece to the 11 pieces and actually getting it down the shaft. So what was the feedback really from the crane driver, obviously with a brand new crane?
Yeah, so I mean the crane drivers, they were very eager to just get in the crane and do what they normally do. The crane drivers themselves had never used this Bluetooth set before, but we were very much of a mindset that the technology exists and we can take people out of the line of fire. So we were really insistent that we wanted to do it this way. So we sent the crane operators with the crane to the Liebherr yard in England. They were there for about a week before then coming to site, and they'd done a detailed training program there to be able to utilize the crane with that Bluetooth handset. And in the end, actually, I think the guys really enjoyed it, really liked being able to be able to walk around the crane as they're lifting. Normally, the crane operator, when he's in his cab, is simply pulling levers and has to very much rely on the slingers around him, giving him clear direction as to when to lift, when to slew, that type of thing. But being able to take the operator out of the cab, he can walk around, he can see things for himself. And in the end, I think it's a really clever way of doing things.
I think the only I'll say negative, the only feedback that wasn't that was sort of erred on the side of caution was that the crane operators were saying when you're sitting in the crane, you can feel the crane, you can feel it take the load, and you can feel the engine working. But when you're then working from a remote control, you lose that sort of haptic feel of the crane. And he was saying if he could replicate that on his joystick, he would be very, very happy. Yes, and yes and yes. There was third-party monitoring, or there was monitoring installed, or there were surveys taken for the Network Rail Bridge, which was readings were taken before and after. In terms of the sewers, access was a problem for one. Obviously, the sewers operate. And a lot of these are on auto pumps, but the bigger ones, the Southern Outfall and the like, they tend to operate with flow. So access to install monitoring is the first problem. Live monitoring on the night was discussed and was planned for a short while. However, the stretches of sewer that needed to be monitored also required a team and a tripod to be set up in the middle of the road that we needed to drive the SPMT down. So that wasn't very practical either. And in the end, through speaking with the asset owners, I seem to remember, but I will happily be corrected, that the feeling was it would almost be too late to do anything. Sort of if you're going, you're going. So the monitoring element came out, and instead we just went with sort of pre and post condition surveys. I think they were the only things that were monitored. The gas mains we weren't able to monitor. There was a concern from SGN that digging down and exposing the gas main, especially the one down Blackwall Lane, Blackwall Lane. It was about 4 meters deep. They were concerned that digging down to expose the gas main would possibly fail it. So they didn't even want us to go and do condition surveys on it.
That's probably it for the assets, but just as a note, we also monitored the system itself. Whenever the load spreading beams on the skid system, we monitored those to ensure that the deflection was within the expected range, just to give us that extra confidence that everything was built correctly and was operating correctly.
Any others?
I guess it's probably just to, I guess, to wrap up from my side anyway. We also had great support from beginning to end from Tideway, both in terms of assisting in the design assessments. They had a pretty far reach within the various different design houses and specialists, and then at a site level as well, both supporting myself and Conor in the meetings and ultimately the delivery. So thanks to Tideway and their team.
Okay.
Vic, they've come for you.
Yeah. I think it looks like we probably have to close with questions. Just give it. Oh, there's no more. Right. Okay. Well, I think on that note, I would just really like to take this opportunity to thank both Rob and Conor for their time this evening and for sharing the challenges that they've encountered, I think persevered through and solved to deliver the Greenwich Connection Tunnel TBM to site. I really hope, and I think if everyone keep their fingers crossed, that the actual drive is a little more straightforward. And hopefully they'll come back and tell us about that in the future. We do have a couple of announcements tonight. So our first announcement is the BTS committee has got applications open for 2020-21 year, and if you could apply by the 28th of October, they would really appreciate. Lots of great things that the committee is doing and lots of things they want to do for the next year. So please get involved, and you can find out more on the BTSYM social media pages or following the Linktree QR code. The next one is that on Thursday, the 5th of November, the BTS Young members are holding their AGM, and their lecture is on tunnel inspection and maintenance. And then on Thursday, the 12th of November, I'll hope you'll be able to join us for the Harding Memorial Lecture, and our speaker is Keith Bowers. Just wanted to do, as we do pretty much every month now, a reminder that we are still producing the BTS at 50 book. Progress is continuing at great speed. However, we are always looking for volunteers, really, to help us make it be something to remember and commemorate the 50 years of the industry and the BTS's existence. So we are also still looking for sponsors, and as this says, who wouldn't want to be on the back cover of the biggest selling BTS book ever? So if you have got time and are interested in sponsoring, please get in touch. And then just one more reminder, if you haven't been able to join us live tonight or not able to join us live for future meetings, please subscribe to our YouTube channel. It will remind you so that you never miss a lecture recording, and you can go and watch this at your leisure again. One more note to just really thank our speakers for their time tonight. It really was an extremely interesting talk and an interesting way of seeing how so much teamwork can come together and achieve great things. So thank you very much tonight, and see you next time.